Hello guys, I am Ali Jawad and welcome to my YouTube channel. In this video, we will go for lesson number 2 on chapter number 7, Pressure of syllabus physics 5054 for Cambridge and O-level students. So those viewers who are new to the lesson, they are requested to go for lesson number 1 to learn the basics on the chapter Pressure. I am providing the link of the lesson over here in the video. The topic of our today's discussion will be hydrostatic pressure, or the pressure exerted by a liquid. In our previous lesson, we have seen the basic formula of pressure and have covered with some examples. Now, to derive the formula of a pressure of liquid, let us assume a cylindrical container which has some liquid in it. The height of the liquid in the container is given by H, while the volume is equal to area multiplied by height. Now note that we already know from the basic definition of volume that volume is length by breadth by height. So if we may combine length and breadth together, it will become area. So volume is equal to area multiplied by height. The force which will be exerted by the liquid on the base of the container will be equal to the weight of the liquid. To know more about weight, please visit the lesson of mass, weight and density available on the channel. So according to the basic definition of pressure, pressure is force divided by area. But in this case, the force acting on the bottom of the container is equal to weight. So in this next step, we can replace force with weight. However, weight is equal to mass times gravity. So we have substituted in place of weight, mass times gravity. The area remains same. And to do a mathematical trick over here, we have multiplied and divided the whole equation by h. Because h will get cancelled out each other and the equation will not get affected in any way. But why we have done it, you will learn it in the next step. So area into height, we already know is equal to volume. So that is why we have replaced it, and in the next step we can replace area into height with volume. So here we get mass times gravity times height divided by volume. But mass upon volume is density. So we can replace mass over volume with a factor of density. So this gets replaced with this variable rho, and gravity and height remain same. So the pressure of liquid is given by density multiplied by gravity multiplied by height of the liquid in a container. Now note that if the height of the liquid in the container increases, the pressure increases. Same stands with density and gravity. They have the direct relation with the pressure. Now, if one may see this diagram in which different containers are shown, so one can expect that the high pressure of the liquid will be exerted in this container, while since this is a very thin long tube, so it will exert low pressure because of lesser amount of liquid. However, this is not the case. Each of these containers exert the same pressure and has the same hydrostatic liquid pressure. This phenomena is known as Pascal paradox, because according to the formula, the pressure depends on gravity, density and height. Now note that height of the liquid in each of the container is same, and the type of liquid is also same. So it means they have the same density, they have the same height, and the gravity which will be acting upon each of the container will also be same. So that leads to the same pressure even though the shape of the container and the amount of liquid is different. So this phenomena is known as Pascal paradox. Now let us discuss something about atmospheric pressure. We know that our Earth is covered with different gases in its atmosphere. There are clouds, there are water vapors, nitrogen, oxygen, carbon dioxide, and other gases are enveloping the Earth atmosphere, enveloping the Earth in such a manner that they form a layer of gases on its surface. So these layers of gases exert the pressure on the surface of Earth, which is known as atmospheric pressure. Now, atmospheric pressure is calculated or determined by help of an instrument known as barometer. So barometer is a simple tube and a trough with it. The trough is filled with mercury and the tube is also filled with mercury. And as soon as we invert the whole tube into the trough, so some amount of mercury flows downward and the remaining mercury left at a particular height. And why this is so? This is because when the atmospheric pressure of the gases in the surrounding acts on the mercury, that tries to push the mercury inside the tube. And because of this, the level of mercury does not decreases from a certain value. Practically, this value is 760 millimeter of mercury at sea level. But if you will go to the higher altitudes, let's say mountainous areas, so the mountainous areas have lesser atmospheric pressure because there is lesser amount of oxygen over there. So the force reduces, and when the force reduces in the trough, so the force is not enough to push the mercury in the tube and the level of mercury also falls. So as we go above the sea level, the height of the mercury in the barometer decreases. Now let us try to calculate the atmospheric pressure at the sea level, means the pressure of gases. So here is a question. A barometer containing mercury as a working fluid with a density of 13,600 is used to measure atmospheric pressure at sea level. The height of mercury observed in the barometer is 760. Calculate the atmospheric pressure. So we know that the barometer consists of this small tube and a trough, and the height of the mercury in the tube is 760 millimeters. So now we can apply the basic formula after forming the data, which is hydrostatic pressure, means pressure of liquid, is equal to rho gh. Rho is the density of mercury. Since mercury is used, gravity is 10 for surface of Earth, but according to the new syllabus, the students should have to use 9.8. And the height is converted into meters because SI unit is meters, so height. And here we get 103,360 Pascal, or if we may use the engineering notation and move the decimal to 3 digits backward, it will become 103.3 kilopascal. So this pressure is equals to the pressure of gases which is being exerted from the surrounding on this mercury. I hope you have liked the lesson. Don't forget to subscribe to our channel to watch the latest videos on the same topic. Thank you for watching.